Hello students, I am Professor Ambika Devi, Assistant Professor of Physics, Government First Grade College, Bidar. Today's video is related to session 34 of BSc 5th Sem, Solid State Physics course which is prescribed in the colleges affiliated to Karnataka State, Gulbarga University, Kalburgi. Let us now begin with the session 34 of BSc 5th Sem Solid State Physics course, and this session is related to problems on BH curve, that is hysteresis loop. Let us take question number 1. We have here the question is the volume of the iron core of a transformer is 2000 centimeter cube. It is fed with AC of 50 Hertz. If the loss of energy due to hysteresis per hour is 36 joules, calculate the area of BH loop. Now this is the question we have. I will write the data for this question. So given data are here loss of energy due to hysteresis per second is given by actually it is given by 36 divided by 60 into 60. It is converted in terms of second, which is equal to 10 to the power minus 2 joule per second. Loss of energy per cycle is calculated by 10 to the power minus 3 divided by 50 Hertz, that is equal to 2 into 10 to the power minus 4 joule per second per cycle. Next is volume of the transformer core is equal to 2000 centimeter cube. Okay. Then here we are calculating loss of energy per cycle per unit volume. That is equal to a loss of energy per cycle is, that is 2 into 10 to the power minus 4, and this is the volume of the transformer core. Then it is calculated as 1 into 10 to the power minus 1, which is the area of BH loop. So students, loss of energy per cycle per unit volume is equal to area of the loop. The next question is calculate hourly loss of energy in a specimen of iron, the hysteresis loop of which is equivalent in area to 150 joule per meter cube. Frequency is given 60 Hertz, and the specific gravity of iron is 7.5. Here weight of the specimen is 10 kg. Okay. Then next is given data are hysteresis loss is equal to 250 joule per meter cube per cycle, and mass of the iron is also given, that is equal to 10 kg. Volume of the iron specimen is equal to it is calculated 10 to the power minus 2 by 7.5 per meter cube. Then number of cycles per hour is equal to 60 into 60, that is 3600 in hour. We are calculating loss per hour, which is equal to 150 into 10 to the power minus 2 by 7.5, that is given here. Then it is number of cycles per hour is equal to 3600. After simplifying this formula, we get the answer 720 joule. The next question is determine the hysteresis loss of iron core weighing 50 kg having density of 8.2 10 to 10 to the power 3 kg per meter cube. The area of the loop is 250 centimeter square and the frequency given is 50 Hertz. The scales on the x-axis and y-axis are 1 centimeter is equal to 30 ampere Tesla per meter, and this one is 1 centimeter equal to 0.1 Weber per meter square. Okay, then here given is hysteresis loss. Hysteresis loss is calculated by this formula xy into these two are the scales along x-axis and scales along y-axis into area of BH curve. Here loss is this one. Hysteresis loss is along x-axis it is 30, along y-axis it is 0.1, and area of BH curve is 250. So we get the 750 as hysteresis loss. See here, density of the material is given 8.2 into 10 to the power 3 kg per meter cube, and volume of the 1 kg material it is 6 into 10 to the power minus 3, which is calculated by using 50 divided by this is the density. Okay, then mass by density. Here we are using the formula for density. Density is equal to mass by volume. It is modified as volume is equal to mass by density. By using the formula mass by density, volume of the 1 kg material is calculated as 6 into 10 to the power minus 3. See here, number of cycles per second is equal to 50 Hertz. Then after substituting all these value in the loss formula, then we get 225 watt as the total loss. Then next question is, the hysteresis loop of a sample sheet steel is subjected to a maximum flux density of 1.3 Weber per meter square, has an area of 60 centimeter square, the scales being 1 centimeter equal to 0.1 Weber per meter square and 1 centimeter is equal to 20 ampere Tesla per meter. Calculate the hysteresis loss in watt when 5 into 10 to the power minus 4 meter cube of the same material is subjected to an alternating flux density of 1.3 Weber per meter square. Here peak value of the frequency of 65 Hertz. Now this is the question which we have in front of us. Based on whatever given in the question, we would first writing the data, then we will solve the problem. Okay, let us now start to solve the problem. The scale of B and H should be taken into consideration while calculating the actual loop area. If the scales are x and y, scales are along x-axis along y-axis, it is given, then loss equal to x into y, that is the values of scale along x-axis, scale along y-axis into area of BH loop. After substituting these three values x, y and area of BH curve, x is 0.1, y is 20 and area of BH curve is 60. After substituting these three values, we get the answer loss is equal to 120 joule per meter cube per cycle. Okay. Then next, volume of the steel is equal to 5 into 10 to the power minus 4 meter cube. Then number of cycles per second is equal to 65 Hertz. Then loss is equal to 120 and 120 into volume 5 into 10 to the power minus 4 and frequency 65 hertz. After simplifying this formula, we get the answer. The loss is equal to 3.9 watt. So in this session, we have discussed about the problems on hysteresis loop. Okay, thank you.